All right, part 2 of simulations and probability. Let's finish up the Monty Hall game. So, what did you decide? Did you decide to stick or switch? Does it matter? Most people think it doesn't matter. They think, I've already chosen, so there's a 50-50 chance because there's only 2 doors left after he reveals one. So, it shouldn't matter, but that's actually not true. I showed you some tree diagrams right here. So it was easier to make a stay tree diagram and then a switch tree diagram. If you try to put the two together, it can be a little complicated. I'm not sure if you tried a tree diagram, but that's one way to do this problem. So if you look in the stay strategy, you choose a door. So notice that you had 2/3 of a chance of choosing a goat, right? Or a bad prize. You only had a 1/3 chance of choosing the car. And if you just stay with that choice, remember the probability that you get a car is only going to be true when you chose it the first time. So the probability that you win if you stay with your strategy is 1/3. But the probability that you lose with your stay strategy is 2/3. So you should not stay. You should switch. If you look at the tree diagram for when you switch, remember, only 1 out of the 3 times did you choose the right door first. So if you look at this second part of the tree diagram right here, there's only this scenario here where you chose the car first and then you lose. In the other scenarios, you win. So it's better to switch, because if you look right here, I picked the car first. Yes, I switch, I pick a goat. That's not a good scenario, but that's only 1/3 of the time. Here, I have 1/3 of the time I picked a goat, but I switched to a car. And then if I picked this door, 1/3 of the time, and then I switch to this other one, I get a car. So 2 out of the 3 times, I'm going to get a car if I switch. So this is very counterintuitive to a lot of people. Look at this tree diagram, think about it, but if you need more of an explanation, let's talk about it. This video right here is very well done, and it's a great example of a simulation. So 2 people do a simulation in here, and because one of the persons is not a math person and he says, oh, intuitively it shouldn't matter. I'm just going to say it's 50-50 chance, 1/2 of the time I should win. The other person, who is a mathematician, knows that he has a better chance if he switches. So they set up a simulation and they run through it, and it's a very good explanation. If you finish it and you want to try your own simulation, there's a link to an activity right here that's Kids Meal Simulation to try. All right, I hope you enjoyed this.